Okay, good day everyone. Alright, so we started talking about this topic in class while we were in the hall, and we reached so we was on section 2, specific objective A, coordinate geometry. Alright, so we already discussed how to find the equation of a straight line. What do we mean by parallel and perpendicular lines? And what is the relationship between the gradients of parallel and perpendicular lines? Right, if you weren't there for that, you'll have to review that from your maths notes. Alright, so today I just want to briefly recall how to find the point of intersection of two lines and how to find the points of intersection of a curve with a straight line. Now, I want you to notice the numbers here. These are, if you open your syllabus, the specific objectives over here are using the same numbers, so you all could follow along in your syllabus. Now remember, at any time during this video you could pause the video and take notes. Remember, the purpose of this is to help you take notes in class while we are in school, right? Alright, so if you recall, one of the applications of solving simultaneous equations is that we could find the point or points of intersection, right? So this is just looking at it from a different perspective. In order to find the point of intersection of two lines, we just take the equations of the two lines and we solve simultaneously. And when we solve it simultaneously, we would be getting the coordinates of the points of intersection. So we will get an x value and a y value. So together that will form the coordinate. Similarly, if you want to find the point of intersection of a curve with a straight line, so all is required is that use the equations and solve simultaneously. So notice they say the points of intersection of a curve with a straight line, and they only say the point singular of intersection of two lines. So two lines could only meet at one point. Alright, so if you have a line here, a line so, they would meet at one point only. But if you have a curve and a line, they meet at 2 points. Now a curve is any shape with any curve on it, right? So therefore you would notice in this section later on we will be dealing with circles. So a circle could be intersected by a line, and it will be intersect at 2 points. So if I have the equation of the line and the equation of the circle, I could therefore use both those equations and solve simultaneously. Now, because you have 2 points of intersection, it would mean that I will get 2x values and 2y values. So just bear that in mind, because you would have to, in order to get 2x values, you would have to get a quadratic equation, and if you were to get 2y values, similarly you may get a quadratic equation in y as well. So you solve for one and then hence substitute and solve for the other one. So what I'll do, I'll just go through some examples and use past paper. So I'll use some paper 2 questions and also use some multiple choice questions that involves these objectives on the syllabus. Okay. Now remember, at any point, anything that I said, you can write it as a note, because everything is important here, right? Okay, so what we have here is on June 2014, number 3A. So the question is, determine the value of k such that the lines x plus 3y equals 6 and kx plus 2y equals 12 are perpendicular to each other. Alright, so the big important word that we see in here is perpendicular. Alright, so we discussed previously in class we have two lines that are perpendicular. What does it tell us about the two lines? Right? Once we see the word perpendicular, we know that this implies that the gradients are the negative inverse of each other. And we did a few examples in class, right? So let's see how we apply it here. This is what this means, right? So therefore I have to look at values of gradient. Now look at what we are given in the question with regards to the two lines. The first line we have, the equation is x plus 3y equals 6. Right? Now I need to know, remember the question is regard to perpendicular lines, so therefore I have to look at the gradients of the lines. So I need to figure out what is the gradient of this line. And as we did in class, in order to do that, we recall the general form of equation line is y equals mx plus c. So I need to make y the subject of the formula. So that's very simple. So we'll solve the equation for y. So rearranging, I'll get 3y equals minus x plus 6. Then I divide each term by 3. So I'll have y equals negative a third x plus 2. So as a result of this, I know that the gradient of this line is equal to negative a third. Right? So that's the gradient of the first line of the line x plus 3y equals 6. Now the second line, kx plus 2y equals 12. So I want to identify gradient. So I have the equation. So we have to try to identify the gradient in terms of k. So we do the same thing. We solve for y, or make y the subject. So 2y equals minus kx plus 12. So divide throughout by 2, and minus k over 2x plus 12 over 2 is 6, right? So the gradient of this line is equal to negative k over 2. Right. So we are told that, so we have the two gradients of the two lines, but we know for certain that they are perpendicular to each other. So a certain value of k here would make this line perpendicular to this line. So as we said before, gradients are the negative inverse of each other. So if this line has a gradient of negative a third, it means that gradient of perpendicular line will be equal to positive, because you have to change the sign, and then you flip it 3 over 1, or just 3. And this is a perpendicular line here. So hence we know, therefore, this value of gradient negative k over 2 must be equal to the value of 3. So a certain value of k will give you this value. So all you have to do is solve for k. So cross multiply, minus k is equal to 6. So therefore k is equal to negative 6. Right? Now I'm not going to do the entire part 2, but I'll just circle of radius 5 centimeters has at its center the point of intersection of the two perpendicular lines in one. Determine the equation of a circle. So the reason why I left this question here, now you cannot do the equation of a circle as yet because I did not teach that as yet. But I want you to notice they talk about the center of this circle is the point of intersection of the two perpendicular lines from part 1. So the reason why I left this question is for us to find that point of intersection. So just as a practice, right? We said before, to find the point of intersection, we just solve simultaneously the equations of the two lines. So let's rewrite the equations of the two lines. So we had x plus 3y equals 6. And the second equation is kx plus 2y equals 2. And we just determine the value of k is minus 6. So this is equation 1. The second equation is minus 6x plus 2y equals 12. Equation 2. Right, so to solve simultaneously, I like to use the substitution method. So from this one here, I know that x is equal to 6 minus 3y. Solving that into this equation, minus 6 by 6 minus 3y plus 2y equals 12. Right, and we just solve, right? So minus 36 plus 18y plus 2y equals 12, 21. Right, 12 plus 36. I equals 48 over 20. This is 428, 12 over 5. So if y is 12 over 5, we know from before, x is equal to 6 minus 3 by y. So this is 6 minus 36 over 5. Right, 6 5 are 30. So that is right. So this is the x value. So therefore the coordinate of point of intersection would be the x value first, minus 6 over 5, comma 12 over 5. Alright, so let's look at some more examples. June 2017, number 3A, part 3. Determine the points of intersection of the circle x squared plus y squared plus 4x minus 2y minus 20 equals 0, and the line y equals 4 minus 6. Alright, so again, we want to find points of intersection, so we just need to use the two equations. So we have one equation here, and this is the equation of a circle, which we will do soon, that general form, and this is our line. So we have two equations. We have x squared plus y squared plus 4x minus 2y minus 20 equals 0, equation 1. And we also have y equals 4 minus x, equation 2. Now, we didn't do equation of a circle as yet, but the question doesn't really concern that equation. It concerns with finding the points of intersection of that circle with a line, which we already talked about, just need to solve simultaneously. Right, so once we see the question asking to find points of intersection, this is all we have to do, solve simultaneously. Alright, so equation 2 is already written in a nice form in terms of y, so I just have to substitute for y in equation 1. So substitute 2 into 1 So you'll have x squared plus 4 minus x to the squared plus 4x is 2 by 4 minus x minus 20 equals 0. Right, so all you have to do is expand out and simplify. So let's do this quickly. So we have x squared plus, right, 4 minus x, right? Plus 4x, and then we could expand this bracket here, minus 8 plus 2x, negative by negative, minus 20 equals 0. And now we expand here, x squared plus, so this is 16 minus 4x minus 4x plus x squared plus 4x plus 8 plus 2x minus 20 equals 0. Right, and we just simplify by the x squared terms. X squared plus x squared, 2x squared. Right, minus 4x that's 8x plus 4x minus 4x plus 2x is, so minus 4x plus 2x is minus 2x, and I have 16 minus 8 is 8, take away 20, so minus 12. Oh, sorry, so it should be minus 2x minus 12. Right, so what we have here is a quadratic equation, and we expect to get a quadratic equation in x because we are trying to find 2 points of intersection, so hence we would be getting 2x values. So we factorize and we solve, right? So you could also notice that this could simplify by dividing through it by 2. X squared minus x minus 6 equals 0, and that would factorize into x plus 2, x minus 3, so x is equal to minus 2 or x equal 3. Right, so 2x values, and we would therefore have two corresponding y values. So when x equals minus 2, y equals, so we just use the equation y equals 4 minus x, 4 minus the value of x, which is minus 2, so y equals 6. And do the same for the other one. When x equals 3, y equals 4 minus x again, because that was the equation for y. 4 minus 3, which is 1. So the coordinates would be, so the points of intersection are, look at the x value, minus 2, comma, the corresponding y value, when it's used minus 2, you'll get 6. And the next point would be 3, 1. Alright, so those are the points of intersection. Alright, so let's move on to another example. Alright, so this one is on June 2018, number 3b. Determine whether the following pair of lines is parallel. So they give us the equation of two lines here. So remember, we're just going to read the question and analyze what it's asking, right? Now we see in lines being parallel. So the first thing we should recall is what we know about parallel lines. We recall that parallel lines have what is so true about them. Parallel lines have the same same value of gradient, because they have the same gradient. Right. So the action determine whether the two lines are parallel or not. So our answer must be whether yes, the two lines are parallel, or no, the two lines are not parallel. And we'll give our reason why. So this is all I know about parallel lines. So I have to look at the gradients of the two lines and determine whether they are equal or not. So let's look at the first line. I need to find the gradient of that line. What do I need to do? X plus y equals 4. Remember, we can find the gradient from the equation of a line by rearranging it in a certain form. We always remember y equals mx plus c for a straight line, because we're dealing with that line. So rearranging that, I get y equals minus x plus 4. Okay, so therefore, what is the gradient? Coefficient of x, which is minus 1. Now we just look at the second line. The equation of the second line, 3x minus 2y equals minus 3. Again, you rearrange. So you'll have minus 2y equals minus 3x minus 3. And I divide by minus 2 because I want to make y the subject. So you'll get, so you have minus 3 over minus 2, which is positive 3 on 2x plus 3 on 2. So the gradient is positive 3 over 2. So the gradient of this line is negative 1 and the gradient of this line is 3 on 2. And we know that parallel lines, for them to be parallel, have the same value of the gradient, but clearly they are different, right? So you have to make that, therefore the lines are not parallel. It must have a reason why, since they have different gradients. Right, because that's all they asked. All they asked was to determine whether the lines are parallel. And we answered that and proved it mathematically. Right, so some past paper questions. And now, what we'll do is quickly at a few multiple choice questions that deals with these topics. Okay. And also we'll look at strategies of answering these multiple choice questions, because remember, you may have to answer them slightly different to the long paper questions. Alright, so the line 7x minus 4y plus 25 equals 0 and 3x minus y minus 5 equals 0 intersect at the point P. The coordinates of P is. Okay, so there are two ways we could go about doing this. We could, well, the way we know for certain is that coordinate P, which is the point of intersection, is the, all you need to require to do is solve simultaneously. Right? Now, as you will notice, you have different values of x and y here. So once you solve simultaneously properly and you get one of the values correctly, you could just figure out what the answer would be quickly. So we could try that. So the first equation, 7x minus 4y plus 25 equals 0. Equation 1, second one, 3x minus y minus 5 equals 0. Equation 2. Now what I'm noticing, I can make y the subject easily here by bringing it on this side. So I have 3x minus 5 is equal to y. Call this equation 3. So we sub in equation 3 in 1. So I get 7x minus 4 by 3x minus 5 plus 25 equals 0. So let's expand. 7x minus 12x positive 20 plus 25 equals 0. 7 minus 5x plus 45 equals 0. So carry that across. You have 45 equals 5x, which means that the value of x is equal to 9. Right? Now, as you notice quickly, the only answer that has a positive 9 is D. And if you check it, we substitute x equals 9. Remember, y is equal to 3x minus 5. So if I say 3 times 9 minus 5, 27 minus 5, 22. And so the answer is D. Alright, moving on quickly. The line through the points P and Q is parallel to the line with equation 3x plus y minus 21 equals 0. The value of k is. Now k is one of the x coordinate of the point P. Now let's look at crucial words here. The line passing through these points is parallel to this line here. Again, when you come to the word parallel, what do we know? They must have parallel lines have the same gradient. So what we have to do is find the gradient of the line passing through P and Q, find the gradient of this other line and equate them, and we'll solve for k. Because why we could equate them? Parallel lines have equal gradients. Right? Okay, so let's try that. So this line here, 3x plus y minus 21 equals 0. As I recall before, to find the gradient given the equation, we need to rearrange it and make y the subject. So y equals, so bring everything else on the other side of the equation, minus 3x minus plus 21. Alright, so checking the battery there. So gradient here is minus 3. Therefore, let's look at the gradient of the line to the points P and Q. Remember, to find gradient, m is y2 minus y1 over x2 minus x1. And the reason why I'm using this formula is because I'm given 2 points. So this is the formula that comes into play when I'm given the coordinates of 2 points. Alright, so let's substitute. So we know this value has to be equal to 3, negative 3, because they are parallel. So y2 minus y1, so 8 minus 2 all over 6 minus k. That value must be equal to negative 3. So this is 6 over 6 minus k is equal to 3. Which implies that, so we cross multiply, this is equal to 3 times 6 minus k. 6 is equal to 18 minus 3k. 3k is equal to 18 minus 6 is 12. Implies that k is equal to 4. That's P. The points of intersection of the line x plus y equals 7 on the circle x squared plus y squared equals 25 are. Now we recall, to find points of intersection, we usually solve simultaneously. But when we're doing a multiple choice, there's some quick method, a quick way to solve this. Remember, all you require is to see if any one of these points satisfies both equations. Now x plus y equals 7. Looking at the values of x and y, the only pair of values where x plus y equals 7 would be 3 and 4. None of the others work. So the answer has to be D. Alright, let's pause the video and resume in a moment. Okay, so continuing here now. A line passes through the point 6, 5 and is perpendicular to the line whose equation is 3x plus 4y minus 7 equals 0. What is the equation of that line L? So let's see what we know about this line. It passes through a point, but then we see something with perpendicular. It is perpendicular to this line whose equation we are given. So again, once you see that word perpendicular, remember two words that stand out: parallel and perpendicular. Once you see a perpendicular, we need to know the gradient of this line to help us find the equation of the other line. Okay, so let's look at this line. We know this line is 3x plus 4y minus 7 equals 0. I need to find the gradient of this line because we're dealing with gradients whenever we mention the word perpendicular. So to find the gradient from the equation, all we have to do is make y the subject. So 4y is already here. We just rearrange. Minus 3x, this will be plus 7. Then divide through by 4. So y is equal to negative 3/4 x plus 7 over 4. So from this I could see that my gradient is equal to negative 3/4. And this line is perpendicular to the other line. So therefore the gradient of other line must be the negative reciprocal of this line, or the negative inverse. So we change the sign, positive, and then you flip it, 4 over 3. Alright, so the gradient of the perpendicular line is 4 over 3. We know the gradient, and we also know that the line passes through the point 6, 5. So just like we did in class, to find the equation of a line, knowing the gradient and a point on the line, we just recall the general form y equals mx plus c. And we know that the gradient here is 4 over 3. The value of x equals 6. The value of y equals 5. This is obtained from the coordinates of the point on the line. So we just substitute. So y is 5 equals m 4 over 3 by 6 plus c. 3 into 3, 1, 3 to 6, 2, 8. So 5 is equal to 8 plus c. And so c is equal to negative 3. So the equation of the line is y equals m, which is 4 over 3 by x minus 3. Now this is what we get for the equation of the line. But look at our answers. Our answers doesn't have no fractional values in the coefficient, so we remove the fraction. So we're multiplying by 3. So if we multiply by 3, we will get 3y equals 4x minus 9. Okay, so again, as you see, which one of these looks like the answer? Bring everything on one side. 3y minus 4x plus 9 equals 0, or the same thing as, if we rearrange and put it on the other side, 4x minus 3y minus 9 equals 0. Which is the answer. Okay, so let's look at one or two other questions, a multiple choice as well. The line y equals 2x minus 7 and the line x plus 3y equals 7 intersect at the point. We have some options here. So once you want to know where they intersect, all you have to do is solve simultaneously. As usual, this is all you have to do. So yeah, y equals 2x minus 7 and x plus 3y equals 7. Equation 2. So as you can see, y is already subject, so we can substitute that here to equation 2. So x plus 3 by 2x minus 7. So x plus 6x minus 21 plus 7x equals 28, x equals 4. Now you could go ahead and substitute x equals 4 into this, but there's only one answer with x equals to 4, so the answer is A. But we could check it. Y is equal to 2 times 4 minus 7. 8 minus 7 is 1. So the code is. Now what you could have also done was take the values here and substitute it into the equations and see if it satisfies the equation. Like for example, if I take x value of 4 and I substitute into this equation, I supposed to get the y value to be 1. And similarly, if I take the x value of 4 plus 3 times the y value of 1, I'm supposed to get 7. Right? You could have tested it with the other values, but this is two simple linear equations that could be solved simultaneously. Right? So the answer there is 4, 1. Alright, so we looked at a question similar to this in the past. The line through the points P, Q and R is parallel to this line. The value of each is. So we see parallel to the line. Parallel lines have equal gradients. So we need to know, looking at this line, 2x plus y minus 10 equals 0. We need to know the gradient of this line. Again, you make y the subject. Y equals minus 2x minus 10. Therefore, the gradient of this line is minus 2. Now, in the previous example we did, they used perpendicular, so we had to find the negative reciprocal. Here, they said it was parallel to this line. So this will be the value of m that we'll be using now, because parallel lines have equal gradients. Equal. Right? So, what is the point? Alright, so we have equal gradients. So what we have to do is find the gradient of the line passing through the points Q and R. And the only way we could do that is to find gradients in two coordinates. We use the formula y2 minus 1 all over x2 minus x1. Alright, so 8 take away 2 over 4 take away h. That answer must be equal to negative 2 because they are parallel, right? So they must have the same gradient. So simplifying here, this is 6 over 4 minus h equals 2. Cross multiply, 6 is equal to minus 2 times 4 minus h. So equals minus 8 plus 2h. So you have 2h equals 6 plus 8 is 14, or h is equal to 7. And so there is D. One more question here before we finish off this video. The points of intersection of the line equation y minus x minus 2 equals 0 and the circle with the equation x squared plus y squared equals 10 are. Now, in a long paper, in a paper 2, what you will do is write both these equations, make x or y the subject, and you solve simultaneously by substituting into this equation. Right? But for a multiple choice, the simpler thing to do is look for a pair of values that satisfies both equations. So now we could test both. We need to satisfy both, right? But let's check the first equation, y minus x minus 2 equals 0. Let's say I take y value from here, right? And I substitute. So we have 1 minus 3 minus 2. Let's see what that value gives me. 1 minus 3 is minus 2. Minus 2 is minus 4. Now based on the equation, it's supposed to satisfy this equation. So when I substitute the x and y value, I'm supposed to get the value 0. So therefore, I can't use this pair of values, 3 and 1. Let's look at, I'm looking at the options. Maybe minus 3 and minus 1 might work because I have two options like that. Let's see. So using the same equation again. Minus 1 minus 3 minus 2. Let's see if that gives me 0. If it gives me 0, then it would be one of the answers. So minus 1 minus 3 is minus 1 plus 3, which is 2. Take away 2, 0. So therefore it satisfies that equation, right? So let's see if it satisfies the other. We need to satisfy both equations. X squared plus y squared equals 10. So minus 3 squared plus 1 squared. Let's see what that equal to. This is 9 plus 1, 10. So therefore it satisfies the second equation, x squared plus y squared equals 10. Right. So minus 3 minus 1 is one of the answers. The question is it which one is the second set of answers? So we need to test the other 2 points. So minus 1 minus 3. If I substitute this into the equation, so y is now minus 3 minus 1 minus 2. So this is minus 3 plus 1, again minus 2 and minus 4. So we can't use that. So obviously this has to be our answer. And we can just verify. If I use it, the same equation again, and I use these values. So this is 3 take away 1 minus 2. So 3 take away 1, 2 minus 2, 0. So it satisfies. And most likely it will satisfy the second equation. 1 squared is 1, plus 3 squared is 9, 1 plus 9 equals 10. So this is the answer. So this is a simpler way to solve this, instead of solving this simultaneously, where we have multiple choice. So therefore you could use a method like this. Instead of doing a long simultaneous way of substituting and simplifying, when you have a multiple question, in some cases it would be easier. Okay, so that's it for this part of the topic. We will continue next time with equation of circles. Okay, thank you.